Hello, DCCP farm participants. Today, I'm just going to give you all a brief walkthrough on how to use our data collection tools. In a separate video, I will record a longer lesson explaining some of the reasons why we want to do such types of data collection, why data collection is important, how it can help you as a farm and as a business. But today, it's just going to be a brief, hopefully under 10-minute video walking you guys through the different data collection materials that we've provided. And so first, I'm going to point you guys to the sheet that every farm should have gotten with the QR code, as well as a checklist and some general tips for monitoring your feedstocks, monitoring your temperature and smell, the smell wheel, as well as information on bulk density and free airspace. First, we'll go to feedstock monitoring. I'm out here prepping my browns for a good turning of my compost this morning. One crucial part of data collection during composting is getting an adequate measurement of your feedstock inputs. No matter if you're a small or large operation, understanding what goes into your compost is incredibly important. When you have finished preparing your materials, make sure to separate them by different feedstocks. For example, here I have woody debris. This is just some shrubs that I cut the other day, and I'm ready to throw them in the compost with some of my food waste. So they're in my bucket. Start up my scale. And I get the measurement. Now, it's important to account for the weight of your bucket when you are measuring your feedstocks. So today, I'll also be measuring an empty bucket. And then to get the total weight of the feedstock, I subtract the weight of the empty bucket from the weight of my full bucket. And for that, we find ourselves at this data sheet. There are links attached to the bottom with more technical information, but this first sheet here, it just has some instructions, some notes. I would recommend reading them. And then a little bit of content about what do the results mean as we put our stuff into the calculator. And this process is relatively straightforward, but to walk you through it, if you have either weights or gallon measurements for your different feedstocks, you're just going to put them in. And these values have been taken from a variety of resources. The NRES On-Farm Composting Handbook, the Green Mountain Technologies Calculator, some extension service from Klickitat County in Washington. And so there's a variety of categories. And what I would do as you put this information in is I would not stress too much about being too specific within your category. Yes, we have loose versus compacted versus like just general grass clippings, right? Um, I would defer to your judgment on which one you think fits the bill. For things like fruit wastes, you could probably also put in food waste, right? And I would be more specific, for example, if you have a bunch of cantaloupes that just were unable to be sold or given away, and you're like, wow, this is a lot of specific fruit waste that we're adding. But for example, if you have somebody like a community composter's drop off food waste, I would put it into the food waste category. And so let's just say 10 pounds of food waste and 10 pounds of wood chips. And we can see that our C to N is balanced, probably need a little bit more water, and we have a total of 20 pounds. Now, this calculator right here is a tool for you guys to use to get a general idea of what your compost pile is looking like. This is not going to be an exact measurement. We are going to run some tests for that. But in general, it's more to make sure that you're generally on the right track and not so much going into crazy land on your compost. You can also put in your values as gallons. So you switch this 10 pounds of wood chips to 1 gallon. Oh, we need to add more browns. We do not have enough carbon in this. All right, so I'll say 2 gallons, still a little bit lower. Maybe we need to add 2.5 gallons of wood. Still a little low. But that is a resource for you guys to help troubleshoot. And then once you guys have a new pile, so you start a new pile, I would just ask you to right click on compost inputs, click duplicate, and you will have a new tab. Remember to throw the date down here, today, 08, 28, 2025. And that will just help us get a better measurement on like at what time do certain feedstocks come in? How have community composters, how much food have they actually brought in at certain times and stuff like that. This tab here, you guys can feel free to play with it if you want. I think the biggest one that you would play with is the percentage of moisture. If your feedstocks are much drier, like they've been sitting out in the sun for a day, maybe you would lower this a little bit. But I generally would recommend not touching it unless you feel very confident about um, the chemical and physical characteristics of your feedstocks. After we have feedstock monitoring, we have temperature and smell. This one should be. Hello again. Um, After I've prepped my materials and I've got everything gathered to start adding things and turning my pile, I need to assess the temperature. Um, it's important to assess the temperature before you turn because as you turn your compost pile and everything gets mixed up, the hot water vapor that has produced the heat energy within your pile is going to escape and be released into the air around us. So it's important that before we turn, we always check the temperature. I've got a slightly smaller thermometer than you guys have. My pile at home is just for me, so I don't necessarily have to go as deep. But it's important that when we take the temperature of our pile, we not only test multiple locations, but we also test at different depths. This will help us understand what's going on within our pile, but we can also make assumptions about the different things that are happening in different places in our pile. For example, the center of your pile is likely going to be hotter than the outside. And what does this mean when we're trying to get even decomposition for all of our materials that we put in? So stick it in, My pile here is about a foot, 2 feet deep. So going in 6 inches is okay. For you guys, you're probably going to want to measure at whatever the center of your pile is, whatever halfway to the center is, and whatever the outside is. So we see here, got my measurement, 70.9. But then I go around to the other side of the pile. We're stopping at 70.1. Now, this is a rather small difference, but it's also important to note that your pile is going to be at least 4 to 5 times the size of mine. And so we're going to see much, much different variations of temperature for some of you farm composters. Be relatively straightforward. You have your sheet, the DCCCP temperature and smell form. You'll select your farm name and then date, the temperature, and you'll stick your hand with gloves potentially and grab a chunk. Just take a few seconds, sniff it, get the texture. A lot of this is going to be for you guys to just get a feel, get up close to not only what your compost feels like, but what it smells like. And as you gain more experience with composting, you can use these observations that you've picked up over time to really get to know how to best manage your compost without needing some super crazy scientific test. You'll also be asked to look at the look and texture of your compost. Again, is it black? Is it light brown? Is it green? Is it yellow even? These are all possibilities. And again, we are going to cross-reference this with physical chemical data in the lab. But these are also for you just to get up tight and close with your compost to really kickstart your working knowledge of the way the process works. We've included a smell wheel here. So you'll see sweet, earthy, musty, lemony, grassy. Sometimes it even gets a little fishy. This is, again, for you, it's just an example. I think the wheel is a nice visualization of how all these things interact. But if there's a word that you think better describes your compost than that's on this list or in the examples, feel free to add it. I'm not particularly sweating, but again, we're going to cross-reference this with some other chemical data, and hopefully we'll be able to provide some recommendations for best management practices going forward. Lastly, we get to what is probably the most complex data collection method that we're going to talk about, and that is bulk density and free airspace. And so what is bulk density? It is the weight of compost within a specific unit of space. And so, for example, here, I have this Tupperware. It's got some beans in it. The beans do not occupy the total space within this Tupperware. And similarly, as we can see here in this graphic, the compost does not occupy the total space within your hypothetical pile or windrow. And so when we're trying to emulate the real-time conditions of a pile within our data collection, we use bulk density for that reason to account for things like free airspace. And why do we want free airspace? Well, it's important for our microorganisms to be able to breathe air. Compost is a matrix. It's got water, it's got particles, and the ability for air to percolate through said particles through the space of a relatively large pile is important as we want to facilitate both safe and efficient decomposition of our food waste. And there are the instructions listed here. We're gonna flick to a short video of me doing said things. So once I have my pile turned, it's important that we get some type of physical assessment of how our compost pile is doing. You, as part of the DCCP, will be helping us assess the bulk density and free airspace of a pile. Now, I've already explained bulk density on the slides, but here I'm going to show you what it actually means to take bulk density. I've got my 5-gallon bucket. I've got my shovel. And I'm going to take some of my compost and put it in my bucket. I'll fill it up halfway. You can use your pitchfork. I've only got a shovel. Once it's about halfway, we drop the bucket. Why do we drop the bucket? Well, normally your compost isn't going to be as small as mine here. You guys are going to have very large piles. And with those large piles, gravity is going to exert force and it's going to compress the pile. So when we drop our bucket, we allow everything to settle into place to get a better idea of what is it going to look like. And now I fill up the bucket. Accidents happen. Now, once you have the bucket up to the top of the rim, to here, just to the rim, we're not going over, we're not going under. Again, give it a little drop. And we'll see some of the compost has settled into place. Now we give it one last filler. Whew, I should have worn gloves. Grody. But now we're ready to take the bulk density. So we're assuming we already took the weight of our bucket, so we know what that is. We don't have to tear that out. If you haven't done so yet, get the weight of your 5-gallon bucket. And we put our bucket with the bulk density on the scale. Now, I'm at home, so all I have is a household scale. I have to stand with my bucket and I subtract my weight. You guys will not have to do that. And once we get the weight of the bucket, all we have to do is divide our weight by 5, the amount of gallons, and we have the pounds for gallons. Next is free airspace. So now that I've taken my bulk density, I just have to do my free airspace. We have our bucket, 5 gallons of compost, and all we need to do is fill this bucket up with water, and then we do some simple arithmetic, and you have your free airspace. That is, what percentage, when we think about the compost matrix within this bucket, there's compost, there's water, but there's also air. So what percentage of this bucket is air? I go, I fill up my bucket. All the way to the top. But let's make sure not to spill anything. This will probably make your bucket pretty heavy. So just beware. If your pile is small, this might affect the amount of moisture that you actually have in your pile when you reapply this 5-gallon bucket back. So if you do have a small pile, kind of like I do, make sure that you add water after you test the free airspace. This will probably allow for better troubleshooting. But it's important that we get this measurement so that we can define and create best management practices for farms across the city. My bucket is filling up, getting close. So now we have no air in this. It's just 5 gallons of water and compost. No air. And so when I step on the scale, it's going to be heavier than it was when we took our measurements for bulk density. Oh, yeah. And so we'll go back to the slides. We'll do some more math. And that is how you take bulk density and free airspace. And then we're going to walk you through some calculations as well. So when you guys are in the field, you guys are probably not going to want to be on a Google form. And so I've created this bulk density and FAS log sheet to help you guys fill it out. And so yeah, I'm plugging the date. Oh, 08, 28, 2025. Say pile 1, sample 1. I don't expect you guys to take more than 1 sample per pile. Although, if you think your pile's not mixed correctly, or if you have a super large pile, it might be worth it to take multiple samples. But it's really up to you guys. And so Well, collect the weight of a bucket. Let's say the bucket is 2.6 pounds, right? And then the weight of the compost with bucket, let's say that's about 15 pounds, right? And so um, if we're following our bulk density instructions, right? At this point, we're in the free airspace part of this, and we are going to want to calculate the weight of compost with water when we fill up our 5-gallon bucket. Let's just say that's 35 pounds. And so the weight of the compost is going to be 15 minus 2.6. So let's say 15 minus 2.6 is 12.4. And then we're going to want to get the weight of compost in water minus the weight of compost with bucket. So 35 minus 15, that's 20. But then we multiply it by 2.4. So 20 times 2.4 is equal to 48. So we are actually at quite a high, in this hypothetical scenario, we are at a pretty high level of free airspace. 48% of the entire matrix is free airspace. And thanks for hanging with me on this quick quick video. I hope this helped. Again, my number is right here, 401-284-8742. I'm going to follow up with a separate video. It's going to be a little longer. It's definitely going to be more technical. So this was just walking you through inputting your values. The next one is going to be why we're inputting values. What are you guys going to get out of it? But this is meant to be a short resource for figuring out how to use the tools we've given you. Take care. Again, my name's Mateo. Contact me here. Goodbye.